One of the concepts we've talked about is albedo, or reflectivity, and radiative energy. And so, for example, the Earth's oceans absorb more radiant energy from the sun than do ice caps, for example, when there are ice caps in the Arctic Ocean or the ice on the Antarctic continent. And so that has to do with the albedo of or reflectivity of the material. So what we're going to do here is a very simple experiment where we've got two containers, one that's black, one that's more reflective. So this has a lower albedo, this has a higher albedo, and we're going to fill these two containers with the same amounts of water, about 50 milliliters of water in each one. So let me go ahead and put 50 milliliters of water in this black container, which you can see is empty. I'll fill it up. Actually, we can put, I think we can put 100 milliliters of water in each of these guys. So let me put another 50. Another 50 milliliters. And here. And we have a temperature sensor on there, so we'll set that there, and then we're going to do the same with the silver container. We'll put a little bit too much there. 100 milliliters of water in the silver, a little bit high. So we've got the same amount of water in each container. We have a temperature sensor in each one. And I've just got them in front of a high power light bulb here, and I've positioned them on either side of the center line. They're the same distance away from the light bulb, and we've got the temperature labeled. They're each at about 22 or 23 degrees. The black one seems to be a little bit warmer already. And I'm just going to now turn on that bright light, and we're getting radiative energy shining on these two objects, and they have different reflectivities. There's the same material and the same amount of mass in each one with water, and we're going to see how the temperature changes, which is a measure of how much energy is stored in them. Since we're measuring the temperature of water, it's the same material, they have the same specific heat. That means the temperature is going to be a directly comparable indicator of how much energy, how much thermal energy has been put into each of these two containers of water. So we've got radiative energy hitting these two containers filled with water, and now we're measuring how much thermal energy is going into those two containers with the temperatures here, and it'll take a little bit of time. So we're just going to monitor the temperatures here on these two containers and see what they do. Already we're starting to see a little bit of a difference. The black container is at 24 degrees C. The silver container is still at around 22 degrees C, and that is because of this difference in albedo, or reflectivity. More of that radiant energy is being absorbed by the black container than is being absorbed by the silver container. It's more reflective, so the energy from the light that's hitting the silver container, less of it is being absorbed and going into it, heating up the container and heating up the water inside. For the black container, it is absorbing more of that radiant energy. The silver container is reflecting more of that radiant energy, and we can see that then reflected. The temperature of the black container is now several degrees warmer. The temperature of the water inside is several degrees warmer than the temperature of the reflective container. So think about that in terms of the Earth as a planet and a system with the sun shining on it. If we have reflective ice, that ice does not warm up much in the sun. It reflects that sunlight. But if we melt the ice, if we raise the temperature of the planet so that the ice melts, it then becomes darker water. The dark water absorbs more of the radiant sunlight incident upon it, and it then heats up even further. This is an example of what we call a positive feedback effect. You melt the ice, the albedo goes down, it absorbs more radiant energy, and it gets even warmer. Conversely, if we cool things down, water freezes, the albedo goes up, becomes more reflective like this silver container, and it reflects even more sunlight and absorbs less, and it becomes even cooler. So those are two examples of positive feedback effects involving whether you're heating things up and melting ice or cooling things down and freezing the planet. And this is what we believe happened at least twice, if not 3 times in the history of the planet, with what were called snowball Earth episodes, where things cooled down, the oceans froze, the planet was covered with a very high albedo or reflective ice, reflected sunlight, stayed cold for a very long period of time, and only was able to heat up because of volcanic activity and geologic energy inside the planet, putting carbon dioxide out into the atmosphere, warming the planet enough to melt the ice, lowering the albedo. We've been going for several minutes now, and here you can see a very dramatic difference in the temperature. The dark material has heated the water up to 35 degrees C. The reflective canister is still only at 23 C. It's absorbed very little of that radiation.